Hey everyone, how you doing? Here's a review lesson to prepare you guys for the geometry work sample problem called moving containers. So here we go. We've got a coffee end cap problem, and we're going to be testing our ability to work a couple different strands of geometry. The ability to apply geometric methods to solve design problems, and the ability to use volume formulas to solve problems. So let's take a look at this. So I'm going to work through this problem. We're going to work through it like it's a work sample. So it talks about things like communication, accuracy, justification, showing your work, all that good business. Plus review some math concepts because for some of you, it might have been a while since you've done geometry or thought about some of these geometric ideas. So here's the problem. Alyssa is setting up an end cap display at a grocery store to display a new brand of coffee the store is carrying. The end cap has dimensions of 4 feet wide. Underline that, seems important. 4 feet wide, 2 feet deep, and 6 feet tall. Alyssa opened up the shipment of new coffee and found that each one comes in a box that is 4 inches by 3.5 inches by 9 inches. She wants to put the largest number of coffee boxes into the end cap display so that customers will purchase more of them. Here's the question. What is the maximum number of coffee boxes that she can fit inside the end cap display? All right, this one involves volume, right? Volume is how much space something takes up. So we've got an end cap. Let me draw that out. So one hint, one thing I'd always recommend if you're doing a geometry work sample is more often than not drawing some sort of sketch, sketching out dimensions, showing your ability to understand and label lengths and angles, things like that. All that is great in terms of showing your work, representing the problems and stuff. So that's what I'm going to do. I'm going to start off just by representing the problem. So let's draw the end cap. So I know it's 4 feet wide. So there's my 4 feet. And it's 2 feet deep. I'm going to do my best little 3-dimensional drawing here. So there's 2 feet deep and 6 feet tall. So it's kind of like envision a big bookcase, right? And when an end cap means it sits on the end of a grocery aisle, and it's usually displaying something they want to display. So shoppers walk by and they're like, ooh, that looks nice. So there's our end cap. All the dimensions, 6 feet tall. The other thing we need to keep track of is the size of each coffee, right? How much coffee fits. So let's draw a little coffee one over here. It's a lot smaller, right? It's 4 inches wide. So 4 inches by 3.5 inches deep. We got ourselves a decimal to work with. And 9 inches tall. So it's kind of taller. It's kind of a tall and skinny little coffee package. Okay, 9 inches tall. And we want to figure out, well, how many of these can I stack and fit inside that end display, that end cap display? In fact, I want to find the maximum number. Now, let me tell you what not to do. A really common mistake. Well, a couple things. First of all, one thing I notice is as I'm working this, here I'm dealing with feet, and here I'm dealing with inches. Whenever you're dealing with volume or geometry or units of scale or things like that, oftentimes you can't compare things unless you have the same consistent units. So either I need to convert all my inches into feet, or I need to convert all my feet into inches. And I'm just going to do that. It's easier to think about my end cap in terms of inches. So 12 inches in a foot. So 4 times 12 would be 48 inches. 2 times 12 would be 24 inches. Whoops, that's a weird 4. And 6 times 12 is going to be 72 inches. So there's the dimensions of my end cap in terms of inches. So I've got that part consistent. Good. Now I need to figure out, well, how many of these can I fit in? A common mistake is people will say, well, volume of a rectangle is length times width times height, right? I'm going to write that out here. So volume of a rectangle, this is helpful to remember, is I need the length times the width times the height. So here's what people do. They'll say, okay, well, this rectangle end cap is 48 by 12, so 48 by 24 by 72. Let me multiply all those together, 48 times 24 times 72. And so we could say, all right, the volume of the end cap then is 82,944 cubic inches. Inches cubed. Then I'll go over to my coffee. What's the volume of the coffee? Well, it's 4 times 3.5 times 9. So let's do 4 times 3.5 times 9. And it looks like one box of coffee is 126 inches cubed. And so then it's just saying, okay, well, let's divide it. 82,944 divided by 126 should tell you exactly how many packages of coffee will fit, right? Fortunately, not. Not in the real world, not when you practically think about physically stacking boxes in and making them fit. Oftentimes there's gaps. Things don't fit perfectly. There might be extra space on the top or the side. And so we want to find the most efficient way to stack boxes in, but hold the most, but we can't just like call it good. Taking 82,944 divided by 126 would work if we were filling our end cap with water and it utilized all the space and we were just filling it up, right? But we don't have squishable water. We have these boxes that have to fit in a certain dimension. We don't really want to squish them all in. That would look bad for our end case. Okay, so what do we got to do? We got to try some different scenarios. We have to think about dimensions and the way we're stacking things up and putting boxes in, right? So let's come up with a scenario here. First scenario. Let me take my box and relative to the end cap here, let's say first scenario, we stack it upright. So it's 9 inches tall, 4 inches wide, and 3.5 inches deep. And let me see if I just put all those in and start stacking them up kind of like this. How many can we fit in? Well, let's start with the front. So along the base front, it's 48 inches along the front. And I've got 4 inches. So 48 divided by the 4-inch width of the box means I can fit 12 boxes along the front edge, right? It's 24 inches deep, and my depth right now is 3.5. So how many 3.5 lengths can I fit? So that's going to be 24 divided by 3.5, which is going to be 6. We can only fit 6. There's a little bit more I could fit, but I can't quite fit 7. I can only fit 6. So we got 6 boxes. And there's that little bit of extra room, right? These boxes aren't going to fit perfectly, so we have to kind of leave out some space. Okay, so I can fit 6 boxes deep. I can fit 12 boxes wide. How many boxes up and down? Well, up and down, or the height is 72. So 72 inches tall, and each box is 9 inches. So it looks like that actually does divide nicely. 72 divided by 9 is 8 boxes tall. So if I align it in this configuration, I can fit 12 boxes wide, 6 boxes deep, 8 boxes tall. That's going to be 12 times 6 times 8. How many total boxes will we fit? 12 times 6 times 8 on my calculator. We get 576 total boxes. All right. There's a possible answer, but it might not be the most efficient answer, is it? There's a couple other different ways we could lay out the box and check to see what's going on. So for example, what if we lay it on its side and I keep it 4 wide, but only 3.5 tall, and I lay it long ways like this. Will I be able to fit more boxes, less boxes? So that's 9 deep, 4 wide, and 3.5 tall. So this is my second configuration. I'm kind of running through some different scenarios. I'm going to see, well, how many will this fit? How many can I stack in? Okay, let's go through the same thing. We have 40 inches wide. That's my container end cap. And I'm still using the 4-inch wide box for that length. So I'm going to fit 12 boxes across. Notice I'm trying to label everything and showing my work really carefully. This time, depth-wise, I have 24 inches deep, but I've rearranged my boxes so that it's 9 inches deep. So divided by 9 means I can only fit 2. There's 2 and a change, right? What is 24 divided by 9? It's 2 point something. 24 divided by 9. It's 2.666, so 2 2/3. So I can only fit 2 boxes. I can't fit any more than 2. So I can fit 2 boxes deep, and then 72 inches divided by, this time I'm using my small height to go up. So 72 divided by 3.5 means I can fit 20 boxes tall if I can do this configuration. So let's check it. What is 12 times 2 times 20 equals 480 total boxes. Well, how does that compare? The first way, when we lined them up tall-wise, we got 576, but if I laid them flat and stacked them that way, we only got 480. So clearly number 2 is not the maximum way. But this is kind of what we need to do. We kind of need to think through scenarios. We need to think through our dimensions and try and find one that actually works. Okay, another way I could rearrange the box. So I could rotate it. Instead of going 4 wide and up 3.5, let's go 3.5 wide and up 4. So it's a little taller, but less wide. Maybe it'll fit a little bit better that way. Still 9 deep. And let's kind of run through our scenarios. So 48 inches wide. This time I'm dividing by 3.5. And how many boxes can we fit that way? So I can fit more now. So I can fit 13. So I've gone a little wider. It's less, each box is a little smaller. And for my depth, it's still 24 inches deep in the end case. And I'm still doing a 9-inch deep box that way. So I can only fit 2 deep. And for my height, 72 inches. My height is now 4 because I rearranged the box differently. And 72 divided by 4 is 18. Okay, so how many boxes does that give? 13 times 2 times 18 is going to be a total of 13 times 2 times 18. On my calculator, I got 468. This is actually even less still. All right, so that's actually the least number of boxes. Can you think of any other ways to rearrange this thing around? Fortunately, I can think of one. Let's go back to tall. And this time we'll keep it tall-wise, but instead of 4 wide and 3.5 deep, let's do it 3.5 wide and 4 deep, but still 9 inches tall. Okay. Going through my scenarios, I got 48 inches total in my end cap. I'm going to divide it by 3.5. And similar to that, I already know it'll fit 13 wide. I've got 24 inches in depth. At this time, rearranging it, there's 4 inches for each box. So if I divide it by 4, means we can stack exactly 6 that way. Okay, that's getting kind of nice and efficient. And then we've got 72 inches in total height divided by the 9 inches of each box. How many boxes can I stack upwards? Well, that's 72 divided by 9 is going to be 8. So now we've got 13 times 6 times 8 is going to be 13 times 6 times 8. 624 boxes. Oops, looks like a 9. Let's change that. There we go. Well, that's the largest one. So we found ourselves a winner. If I specifically align up my boxes in this configuration, I'll be able to fit actually quite a bit more. So 576 was the next highest. I'm figuring that's 24. That's 48 extra boxes just by rearranging them a little bit differently in the end cap. So how do I want to answer this, right? I've done all my work. I've showed a lot of work. I still got to do a work sample where I need to kind of summarize, communicate, do all that stuff, right? So let's kind of rewrite it all out. If we line up the box, I'm going to try and write it here, to be 3.5 wide, 4 inches deep. Well, let me actually use inches. 3.5 inches wide, 4 inches deep. By the way, that little apostrophe looking thing, that's the notation for inches. And 9 inches tall. We will fit 624 boxes into the end cap, which is the maximum. Okay, there we go. That's a pretty good looking work sample right there. I can interpret the problem. I drew out diagrams. I labeled things. I labeled formulas. I showed work. I made sure to label kind of what my work meant for each section. So you can see there's 4 different examples. I see the units converging, making sure we're comparing the right inches to feet, inches, all that kind of good stuff. And then I answered my question at the end really thoroughly. And this kind of even summarizes. The only part I didn't really do was kind of recheck my work in a way that's sort of justifying it, right? I kind of wrapped up my answer and I showed my work to get to the answer. The only other thing I would need to add would be checking the volumes of each one and making sure that I didn't make a mathematical mistake somewhere. I'm kind of revisiting our process. So that's part of passing work samples, actually revisiting the process and saying, yes, we looked at different configurations. We rearranged them and figured out how many would fit using the volume formula and double checking my work. Yep, number 4, that configuration got the most number of boxes. Hopefully this is helpful for you guys. I know it took a while to get through this, but I wanted to make sure we kind of revisit a lot of these ideas. Good luck as you're doing your geometry work sample.